Annyeonghaseyo and greetings from Bemidji, Minnesota, ninth graders. So today's lesson is all about weather and climate, but actually what we're going to do today is we're going to change things up a little bit. We're going to rewind. We're going to go back to our lesson from April 22nd, and we're going to just review what we learned then about the Great Ocean Conveyor Belt, ocean gyres, and Great Pacific Garbage Patch. The reason why we're going back to this is because you have your writing assignment. I've been looking at your writing assignments, and it looks like it would be beneficial, would be helpful for lots of you to review this material. So we're going to do that today, and our objectives are: number one, I want you to understand the steps that takes plastic waste from litter to the inside of our bodies. And if you understand that, then you can do number two. You can write an academic essay describing how plastic pollution ends up in our bodies. So let's go ahead and begin by talking about plastic pollution. This is kind of the thing that I think most of you struggled with in your writing. I thought this was something most of you would be familiar with, but maybe it'll help you to just kind of go over these details one more time. So plastic pollution, most of the plastic pollution in the ocean comes from discarded fishing nets from like big giant commercial fishing vessels. However, a significant amount of plastic pollution comes from people who just throw stuff away on land, right? You have these one-use disposable plastic items like water bottles, plastic bags, eating utensils, straws, whatever. They throw it on the ground, and that eventually makes its way into the ocean. The way it makes its way in the ocean is through rivers and waterways. So for example, plastic bag gets thrown on the ground, it gets blown around by the wind, and eventually it finds itself in a storm sewer, right? It rains, it gets washed into a storm sewer. The storm sewer carries that plastic bag into a river. That river eventually will carry it into an ocean. So this is a picture of a polluted river. You can see it's just choked with plastic. Even this PowerPoint background, if you kind of squint at it and look carefully, you'll see it's an image of a river that is also choked with plastic. So now I just want to touch a little bit on the Great Pacific Garbage Patch. The Great Pacific Garbage Patch is created by our ocean currents. Our ocean currents tend to carry plastic debris into these areas called gyres. Now a gyre is a space where the current carries plastics, but it also kind of slows down, and gyres rotate very slowly, and so this plastic, instead of getting carried out, just gets carried deeper and deeper into this spiral. That's the Great Pacific Garbage Patch. The Great Pacific Garbage Patch itself is about twice the size of Texas. It's located between Hawaii and San Francisco. And if you look at this image, you'll see that it's kind of like light blue on the outside, and then kind of green and yellow and orange, and then finally red. And that represents the sort of concentration of garbage. So on the outer edge of the Great Pacific Garbage Patch, you might not see a ton of debris. First of all, like a lot of this plastic debris is just kind of a little bit below the surface of the water. But second of all, it's going to be kind of spread out. But as you get closer and closer, it's going to get more and more concentrated. This image is not an image of the Great Pacific Garbage Patch. The reason why I can tell right away is because I can see land in the distance of this image, and so that's telling me it's not the Great Pacific Garbage Patch, because the Great Pacific Garbage Patch is located too far out for you to see land. Nonetheless, the Great Pacific Garbage Patch is full of plastic waste. Probably in the center, you'll see a concentration like is shown here. Probably on the outer edges, you probably won't see as much garbage. So one of the other things a lot of you were struggling with in your essays was discussing, one, how plastics become microplastics, and then two, how those microplastics get inside of our bodies in large quantities. So that's what we're going to talk about next. So first of all, as I mentioned before, plastic, it never goes away. It sticks around forever. Even though it doesn't go away, it does break down into smaller pieces when exposed to sunlight, and that's called photodegradation. And plastics will break down in smaller pieces when exposed to direct sunlight. This process probably takes about 3 months or longer, but nonetheless, these pieces get smaller and smaller, and eventually these pieces are so small that they're carried by the wind, which is why we find plastic on mountaintops. These small pieces of plastic get carried by ocean currents, which is why we find them in deep ocean trenches. These small pieces of plastic are small enough to seep into the groundwater and find their way into aquifers, which essentially are underground rivers where, when we dig wells, we tap into an aquifer and we draw water out of it. And when I say we're finding water in these aquifers, it's not because we have an open well and the plastic is blowing into the well. It's because these microplastics are small enough that they can travel with water in between grains of sand that are in the ground and make their way into aquifers and make their way into wells in which we get drinking water for our schools, our homes, our apartments, whatever. In addition to that, microplastics are not only bad in and of themselves, but they're worse because other pollutants and other carcinogens, which are cancer-causing agents like PCBs and PAHs and heavy metals, they can stick to these microplastics. This is an image of microplastics on someone's finger, and this is not as small as microplastics get. We can still see these microplastics, so it's definitely not as small as they can get. Microplastics can be small as 1 nanometer, and I of course can't show you what that is because we can't see a nanometer. We need a microscope to see a nanometer. And so microplastics are small enough not only to get inside of animals and big things, but they can also get inside of single-celled organisms or even bacteria. Now let's go on to this topic of biomagnification. Now, this picture shows us biomagnification with PCBs, but we can also use it to understand how it happens with microplastics. And so at the top of the picture we have phytoplankton, which are basically single-celled plants that live in the ocean. And so these phytoplankton are the basis of the ocean food chain. And we can see that not every single phytoplankton has microplastic within it. So let's just say that out of every 20 phytoplankton, 3 of them will have microplastic in it. Okay, and then when we go up the food chain, our next consumer is, we'll just say, a shrimp. And the shrimp, we'll say, eats 20 phytoplankton every day. So every day, the shrimp is adding 3 more pieces of microplastic into its body. So 3 times 7, end of a week, the shrimp has 21 pieces of microplastic in its body. Then that shrimp in turn gets eaten by a herring. And herring not only eat 1 shrimp per day, let's just say that herring eats 3 shrimp per day. And it does it for a week. So now we've got 21 times 3, which is 63, times 7, which, I don't know, it's late. It's a big number. But, as you can tell, this number is getting big. And so, now we have herring, which are loaded with microplastic. And those herring, in turn, are eaten by salmon. And that salmon's not going to eat 1 herring a day. It's going to eat multiple herrings a day. And after a course of a week, then, that's going to be times 7. So we can see how plastic accumulates as you go up the food chain, and we're not even to the end of it because people eat salmon, right? And when we eat a salmon, then we get all of these microplastics in our body as well. And so this is the way that plastic accumulates as you go up the food chain. It's called biomagnification. It's something that we've seen before with things like pesticides and other pollutants. So it's a very real thing, and it's a very real concern that people have. If you have any questions about any of the topics that we covered for your essays, please send me an email at sjkwok@sejongacademy.org. You can also hit me up during office hours every day from 9:30 a.m. to 10:30 a.m. And finally, you can also just send me a message through Google Hangouts. Some of you are doing that as well. So hopefully you can contact me if you have any questions. Hopefully this review session was helpful for you. Otherwise, have a great day, and tomorrow on Thursday we'll have another review session as well. Peace.